여러분 안녕하세요. 저는 마르코입니다. 감사합니다. Sorry, my Korean is very limited. I hope you're okay. Now, this morning I'd like to, still morning, yes. This morning I'd like to show you something, robotics on AWS IoT. But before we get to that, short introduction of how you should maybe do it. Speed. No matter what you do, doesn't matter what kind of company you are in, speed wins. Speed wins in business. And how do you get speed? Well, there's many ways, but one way is to focus on your product. Focus on your customer, focus on your solution. You need all the other things to run your product. You need compute, you need storage, you need databases, you need machine learning, etc. They are useful, they are good, but they are the machinery. They are not your product. Your product is on the top of the stack, your features. That's why your customers use your product, for your features. So you want to move up the stack. Everything else, the machinery underneath, if you can, don't do it yourself. One option is to use the cloud. Why the cloud? What is the cloud? Well, at Amazon Web Services, we have now been in production for 10 years. We have a cloud here in Korea. The main point of the AWS cloud is exactly that. You don't have to do all the machinery yourself. We have over 70 services now on the platform that you have been asking. The roadmap of AWS comes from you, mostly, the customers. And the services we have are the building blocks, like Lego building blocks, that let you focus on your product and automate the machinery underneath. You have automatic databases, automated big data analytics, machine learning, push deliveries, etc. So that enables you to focus your effort on the top, your product. Now, let's talk about Internet of Things. Internet of Things are a little bit weird. They are not the same as normal software products that run in a data center. With the Internet of Things, you have weird protocols. Why? Because the IoT devices are usually, or quite often, very small and very cheap. Maybe the IoT device has to cost $5, $10. It doesn't have the horsepower or the network bandwidth to handle the full-blown internet protocol stack. And the scale. We have customers who have thousands, potentially millions of IoT devices connected. They might be floating in the sea, measuring the sea temperature. They might be in the rice fields, might be in all the bus stops, etc. So scale, there's a lot of devices potentially. Security. IoT devices are out there. They are out there in the real world. So anybody potentially can go, take the device, find it at the bus stop or in the rice field, take it, bring it home, plug it to their computer, and analyze the memory or storage. So it's even more important to handle security well with IoT. And then you want to integrate the IoT devices in the field with a centralized system to know what's going on, to gather the data, and to send commands back to the devices. So that's why last year we introduced a new platform, AWS IoT platform. How is it useful? Well, you can connect billions of devices. That's with a B, billions of devices. So don't worry about the scale. Network, we support the lightweight communication protocols of IoT, like MQTT, very handy over like 2G, even GPRS, etc., weird, small radio connections. Security. There is no insecure option. If you use AWS IoT platform, the only way to connect your devices is with high security. We introduced the standard internet security technologies of X509 certificates and keys. So certificates for authentication, this is my device, and keys for encrypting end-to-end communication. That's it. There's no other way of communicating. And you can always revoke the keys. You can revoke the certificates if needed. And then, remember, you might have a lot of devices. They might be sending a lot of data. So the cloud is really the best place to receive this data because it's unlimited scale. So any number of devices sending any amount of data, no problem. So we can receive the data in the cloud. You can store it at any scale. and then you can compute, analyze it at any scale in real time. And when you have done the analytics, you have the insights of the data, you know what's going on, you can make a decision. How does it work? Well, like this. You have your things on the left, your physical things. They are connected to the AWS IoT platform with security, certificates and keys, authenticate, encrypt. And the things are communicating with our device gateway, up to billions of devices. Then an interesting thing, the rules engine. So when you start sending data from your devices to the cloud, with one line of code, one line of SQL code, pretty much everybody knows SQL, you can inspect all the packets coming in and act on them. One line of code. For example, you send temperature information from all the rooms in COEX to the cloud. So then you can have a rule, one line of code. If temperature greater than 25, then action. Action what? Send a command back to air conditioning, go to 23 degrees. So with the rules engine, you can act on the data immediately, packet by packet, and you can also split the data to different destinations. Real-time analytics with Kinesis, storage, S3, NoSQL database, DynamoDB, more processing on the data with Lambda cloud functions, serverless computing, or anything else, it doesn't matter. These are just examples. You have a device registry where you can keep information on your things. But what about when they are not online? What if you want to control a vacuum cleaner and now it's sleeping? How do you talk to a vacuum cleaner? What is the IP address of a vacuum cleaner? Who knows? Nobody knows. That's why we have a cool feature called the device shadow. Every physical device that you have has a virtual representation in the cloud. Physical thing and a virtual thing in the shadow. You can always talk to the shadow with RESTful JSON, normal web programming. And then the shadow will send the commands to the real device. We will take care of finding where the device is, using the protocols that the device uses, and communicating securely. You don't have to worry what is the IP address of a vacuum cleaner. So then you can have your backend system, or even your mobile applications, commanding the physical things using the shadow very easily. So your mobile app can command the shadow of the vacuum cleaner, and vacuum cleaner gets a command, start cleaning the living room. Because you have things, you need to program the things. You also need to now program the physical devices. So you need device SDKs. That's why we created also new SDKs for AWS. We have C language embedded operating system SDK. That's great for industrial controllers. Those boards that cost $5, $10, because C is the most compact one. One example, our MediaTek one. With C, our SDK is 6 kilobytes of code. 6 kilobytes, not megabytes, not gigabytes. 6 kilobytes of code. For those IoT devices that have Linux, like Edison, Raspberry Pi, BeagleBone, etc., we have a Node.js SDK. Easier to use when you have Linux. And then we have an Arduino SDK because Arduino is just cool and it's very popular. Already from the launch last year, we have a partnership with device manufacturers, Intel, Qualcomm, Broadcom, Texas Instruments, etc. These guys make the boards. They make the CPUs and chips. All of them are different. And that's the point. Together with our hardware partners, we have made an optimized SDK for every one of these chips. So every one of these boards has the same developer experience. Single line of code to create an AWS client to talk to DynamoDB, S3, whatever. Single line of code to act, like send data. And all of these have the high security of certificates and keys for encryption and authentication. Some examples. General Electric, GE make huge turbines, very expensive things. They have a lot of sensors that are streaming the data to AWS cloud. General Electric do artificial intelligence analytics on AWS and send back optimized parameters to the turbines. Philips run their medical IoT platform on AWS. They have 190 million patients connected with those medical wearables, they have collected 15 petabytes of data, and they are now able to do data-driven medicine, hopefully making people healthier. That's the important things in life. BMW. The new BMW cars like 7 Series and i8, pretty cool, maybe one day. They have a lot of sensors, so they can see things like maybe gearbox oil is running low. And the new BMW cars, they have a shark fin antenna on the roof. So if you tick the option connected drive, if you buy a BMW, your car has an internet connection. It's actually connected to AWS. And for example, when the BMW cars drive around, they are updating the maps. So when the government builds a new road, maybe changes the speed limit or direction of the road, BMW cars start going the other way, they can analyze it in the cloud and update the map tiles and push updated maps to the cars. So BMW cars are improving the maps by themselves as they're driving around the world. And then NASA, our great technology partner and customer, for example, Curiosity in Mars. All the data coming from Mars is received by NASA and then stored in AWS for high durability. They can't lose it. You get this data once from Mars. You really don't want to lose it. Then they use tens of thousands of cores and servers in AWS to quickly, in parallel, analyze the data and get the results. Because time to results is critical for NASA. The faster they get the results, the faster they can send a new command back to Mars. Now, no more slides. Let's have a demo. And this is a live demo. No recording, no screenshot, no video. Live demo. Is there anything wooden here? I'd like to show you robotics on AWS IoT. So I need a robot. So first I was thinking I will build a drone. Then I was thinking, it will take me a year to build a flying drone. No, let's buy a product. Okay, then I was thinking I buy a drone. But I'm not the best programmer in the world, so if a drone is flying with my code on it, somebody's gonna get hurt. No. Let's have something safer. So I went and I bought a Sphero. A Sphero is a really cool robot, but it's a little ball, so it's quite safe. Nobody can really get hurt. But it's quite sophisticated. It has a lot of sensors, it has gyroscopes, it has accelerometers, and you can control it with Bluetooth. Okay, Bluetooth. Now I need an IoT board that can talk to the robot with Bluetooth. So I went to my cupboard, look, dig, and I found an Intel Edison. Yes, I have a cupboard like this. And why did I choose the Edison? Because Edison has Bluetooth built in, it has Wi-Fi so it can talk to the cloud, and it has Linux so I can install SDKs. Okay, so I did this. I took my Edison, it's here, and I installed 2 SDKs on the Edison. First one, AWS IoT SDK to talk to the cloud. Second one, I found an open source robot SDK called Cylon. If anybody's watching Galactica, silence. So with the Cylon SDK, I can control the robot with Bluetooth from Edison. So let's see that. That's demo step 1. I have 3 steps for the demo. Again, live demo. So here we have the Edison. I'm logged into the Edison, but before that, let me show you the cloud a little bit. So you may have seen this. This is the AWS console. So typically, people start using the AWS cloud platform using our web console first. Here we have over 70 services. They are grouped by things like compute, so servers, containers, cloud functions, serverless computing, storage, databases, etc. And we have the IoT platform here. Okay, this is the console of AWS IoT. Here I have, for example, my things. So I have, for example, an Edison. And then I have security certificates, I have security policies, what are these things allowed to do after they authenticate, and then I have rules, actions to act on the data. If we look at the Edison thing, it's here on the table, we can also see that it has a shadow. So here's the shadow of the Edison. There's some information you can store in the shadow. And you can see something like color equals green. I'll come back to that later. Then we also have an MQTT protocol client in the console. So we should be able to monitor the messages coming from IoT devices right here in the console, kind of debugging, if you will. So let's subscribe to messages that the Edison should be sending once it's working. So I will connect my console to the same messages, same topic that Edison will be using. The topic, because my robot is called Sphero, my topic is called Sphero. There. Right now I don't have any messages, and again this is a live demo, no video recordings for you. There you go. No messages at the moment. Where's my robot? You might be wondering. He said he has a robot. Well, here it is. Here it is. It's a little ball like that. Well, it's pretty cool. It's really sophisticated. This is the developer version, which is transparent, so you can see what's inside. It's funny to see the gyroscope spinning there. Okay. First thing I could do is calibrate the robot. Because the robot is a ball, it's physically a ball, I have no idea which way it's pointing. So now I started a small app on the Edison with a calibration mode. So now the robot is on, you can see there's some lights, and there's a blue light, there's a really bright blue light. That's the backside of the robot, that's the bum of the robot. Okay, so I know that that's the backside. So if I point the backside here, that way is forward, fine. Now I know which way the robot is pointing at. Okay, I exit the calibration app. And now let's start driving it. So I start an app, a little Node.js app that I made, that uses two SDKs. The robot SDK to control the robot with Bluetooth, and the AWS IoT SDK to connect this robot to the cloud. Okay, let me put it on the ground here. There. And if we are lucky, if everything is fine, maybe the robot will start driving. Yes. Forward, go right, back towards me, stop. Let's go a little bit slower. I change the speed. See, now it's going really slow. Okay, you cannot see anything. Back to the video, there. I'm using my iPhone as a video camera here now, so you can see. Anyway, now we are driving around. So that Bluetooth control seems to be working. And when we look at the cloud, aha, here in the AWS IoT platform, we can see messages. Action stop, action left, action back, right, forward, stop. Okay, so we can see that we are controlling the robot, it's moving, and the cloud is getting a copy of the messages, the actions that are happening. So now in the cloud we know what the robot is doing. Okay, why is this important? Let me disconnect from the robot. Why do we want the messages in the cloud? Well, because we could do something funny. For example, let's try to give our robot a voice. It's a nice little robot, it's fun to drive it, but it doesn't say anything. It's quiet. How about we give our robot a personality? One way to do it could be to use an IoT board that has sound output. So I went to my cupboard again, I went digging, and I found a Raspberry Pi. Why did I choose the Raspberry Pi next? Because Raspberry Pi has a sound card, so I can play sounds. So my sweetie recorded some cute sounds, and I connected the Raspberry Pi also to my system. So I installed the AWS SDK on the Raspberry Pi, and the Raspberry Pi subscribes to those messages. So it should get a copy of all the actions the robot is doing. And then it can use the speaker system to play sounds, like this. If I start rolling the robot, driving it, the Edison sends a Bluetooth command with Cylon SDK, robot is going, and the Edison uses AWS SDK to send a message to the cloud. The cloud is forwarding the message to Raspberry Pi. Raspberry Pi gets a copy of the message and plays a sound. Go, go, go. If the robot is sending an event, I have a collision. That's a Bluetooth message to Edison. Edison, with my little app, sends a message to the cloud. Collision message goes to Raspberry Pi. That plays a sound, ouch, in theory. Let's see the demo. Let's see how that works. So now the difference is that we will also use the Raspberry Pi. Here I am, I'm logged into my Raspberry Pi, that's right here. And I will start another Node.js app on the Raspberry Pi. This one is very simple. Log into AWS Cloud, authenticate with keys and certificates, and say, I would like a copy of the Sphero messages. That's it. And if it gets a message, it will play a sound, a corresponding sound. All right, let's start the driving app again on the Edison. So we connect the Edison to the robot again, Bluetooth and IoT. Let's see, maybe I need to move the robot a bit closer. Maybe she was too far. Let me try again. Just a second. Yes, it's a live demo. Edison opsimnida. All right, let me log in again to the Edison. Give me a second. Okay, calibrate again. I think the robot was too far when I was trying. All right, calibration good, connection good. Let's start driving it. And now let's see what happens.
Hello.
What is that? Now when we control the robot, the Raspberry Pi gets a copy of the messages. So let's see what happens when I start driving it.
Go, go, go.
Let's change the speed.
Whee!
Let's go faster.
Go, go, go. Ouch. Whee!
Let's go slowly. Let me show you with video camera. Give me a second. There we go.
Go, go, go. Ouch.
Let's go faster.
Whee! Ouch. Go, go, go.
How about in another language? What if I press a key on the Edison that sends a message to the cloud, change the language?
こんにちは。
Konnichiwa.
行きましょう。痛い、痛い。
How about
你好。
你好?
快乐，快乐。 안녕하세요.
안녕하세요. 한국어입니다.
비켜, 비켜. 비켜, 비켜.
Pick up. Let's hit the wall. Let's see what happens.
아이고, 아이고.
아이고.
비켜, 비켜.
비켜,
아이고,
비켜.
아이고.
There you go. So you can see that the Raspberry Pi is receiving messages, accent collision, accent language equals Korean. So very simple coding on the Raspberry Pi, just change the language files. That's it. All right, that was the second part of the demo. Now the robot has a personality and she can talk 4 different languages. One more thing. That's cool, that's sound coming out, that's voice for the robot. How about if we can talk to the robot using our voice? I have a Finnish accent. Well, let's try anyway. What if we try to talk to the robot using Amazon Alexa voice service? That was the third part of the demo. So I'd like to do this. I'd like to use Alexa voice service and talk to Alexa and say something like, Alexa, tell Sphero to change color to orange. Currently you can see it's green. Alexa lets you customize your voice commands. So I have made a custom skill called Sphero. I implemented the skill with Amazon Cloud using our AWS Lambda function because servers are so last season. So I made a Lambda function in our cloud that is able to receive a message from Alexa and get the information, what is the color that the robot should be. So Lambda function executes in AWS Cloud, that receives the information and then modifies the shadow of the robot, shadow of the Edison, to change the color information. Our IoT platform forwards the shadow change to the Edison, and then Edison uses again Bluetooth and sends a command to the robot, your color should be whatever is orange. So let's try that. With Finnish accent, yes. Let me change the audio to my phone. And let's see how this works. Okay, first of all, let's do a test. Alexa, are you here?
Yes, I'm here. I listen when you press the mic button.
Okay, as you can see, currently the robot is green. Let's try this now. Alexa, tell Sphero change color to orange. I'm trying my best to pronounce. Let's see. She's thinking.
I changed Sphero's color for you.
Oh, orange, Simnida. Okay, one more time. Alexa, tell Sphero change color to green.
I changed Sphero's color for you.
Let's do it one more time in kind of debug mode. So that was using Alexa, right? So Alexa, how did it work? I will show you. This is my Alexa developer site, so developers.amazon.com. I made an account, and I created a skill, a custom skill for Alexa called Edison Sphero. That's the little Edison there. So what do we have here? First of all, there's an invocation name. What is the word that I should use when I talk to Alexa? The keyword. The keyword in this case is Sphero. Okay, so if I say Alexa, tell Sphero, then it should activate this skill. Tell Sphero what? Well, let's look at the interaction model. Aha. So there's an intention. What is the intention? What do you want to do? Tell Sphero to. The intention is to change the color from a list of colors. And because I'm a lazy developer, I have a very limited list of colors. I will add some more later. The idea is this. I should be able to say, Alexa, tell Sphero, activate this, change color to one of these colors. Okay. How does it actually work then? If I say that, what happens? Well, I made a Lambda function. So what happens is this. Alexa will simply execute my cloud function, that function. That one is pointing to my AWS account, to an AWS Lambda function, which is serverless computing. So I made a little function that just executes the moment Alexa calls it. And the function will receive the message from Alexa, what is the new color? And the function will then use the shadow information, update the shadow. This is my AWS Lambda console. This is the function. We can see that the trigger for this function is actually Alexa skill. And if we look at the monitoring, we can see that this function has been executed now. This was me testing it earlier. And just now I did it twice, right? So we have two counts, two executions of this function. All right. Let's do it manually once. So we go to the IoT console. We want to update the shadow of the robot. See, currently it's green. And if I change this manually, I type here orange, and I click update shadow, bang, it goes to orange, right? So I changed the shadow in the cloud, oops, and I click update, and AWS Cloud took care of figuring out where is the Edison. Edison received the message and then updated the code here. This is the actual code running on the Edison. Very shortly show you, I use the Cylon SDK, the open source Bluetooth robot SDK, and AWS IoT SDK. What else? We connect to the robot with Bluetooth here. There is the thing shadow. And When there's a delta in the shadow, when there's a change in the device shadow, well, I have only implemented green and orange, we use the Sphero, the robot SDK, to change the color. So if Alexa lambda function says that the shadow should be orange, we use the robot SDK to change the color of the robot to orange. How am I driving the robot? Like this. If I press the space key, I read the value of the space key, we stop the robot and we send action stop message to the cloud, and so forth. And if I press the L key on the Edison, it changes the language, sends the updated language information like Korean to the cloud, and then Raspberry Pi will start speaking Korean. There you go. So that was a short demo on that. Hope you enjoyed it. With AWS IoT, anybody can connect a device. The only way to connect the device is secure, and it's super easy to get going. You can buy those starter kits, that's what I did, and start hacking and having fun. Thank you very much. Kamsahamnida.